Okay, this is Mr. Great Tech Review here in Mr. Great Tech Review Studio, bringing technological updates here in Mr. Great Tech Review Studio. And on today's tutorial, we are going on tutorial number 19. On tutorial number 19, we are going to do a little practical, and also we are going to do a little linear equation calculation. And we are going to find the slope of the line of the graph, and we are going to do our practical to have a dimmable LED, light dimmer, using our LED. On today's tutorial, here I am, Mr. Great Tech Review, here in Mr. Great Tech Review Studio, bringing technology to your doorstep. So let's dive in and see what we can do with our LED on our dimmable LED project on tutorial number 19. So now let's start and see. Okay, now with me, I have this on the table here. Can zoom it up so that for you can see and see. Okay, so I have this. Okay, you can see the LED, and this light emitting diode, this 470 ohms resistor. And come very close, you can picture it. Okay, I like the shot. I have my light emitting diode, and I have my 470 ohms resistor, and also I have my 50k variable resistor, and I have my connections here. So now you turn the 50 kilo ohms variable resistor, you can see the light emitting diode is going down, is going down, is going down, is dimming, is going down, and it gets to off position, and you can turn it back again, and you see that it start coming up, 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 and you get to what? You get to the full brightness. And before we can go into the programming, I just want to show you the hardware. What you need, you just need a variable resistor, one LED, any color of your choice, one resistor, fixed resistor, which is 470 ohms resistor, and you can add a buzzer if you like. If you add a buzzer if you like, for example, you can see what will happen to the buzzer. The buzzer will come to its full sound when the light is on its full brightness, and you see as it's going down, the buzzer sound is going down, it's going down, it's going down, it's going down till you will not hear anything again. So that is light dimmer for you. And how can we achieve this project with Arduino Uno? Now you can see I have my Arduino Uno here, the Uno board with me here. I made use of pin. Okay, let me bring it so that the camera will pick it very well. So I have my Arduino Uno with me here, and that is it. And I connected to my computer where the program has been written in IDE, Integrated Development Environment. Okay, so that is it. I will show you the program. It's a very simple program combination of analog read, analog write, and a little bit calculation, and the serial monitored, serial begin, serial print in line, and finish. That is it. It's a very simple program. It's a combination of what? Analog read and analog what? Analog write. In analog write, you have the scale value of what? The analog write, you have a scale value of what? 255, sorry. And in analog read, you have a scale value of what? 1023. Now, how can we combine these two scale value? Because you read with your potentiometer at a scale value of what? 1023, and you write to the LED on a scale value of what? Of 255. So 1023, 255. So we are going to find the equation that will combine these two values. Because if you want to write to the LED on 1023 scale, before you know it, before you get to 255, you find out that you have no value again. You just stuck there. That is where you are going to be stuck. So for you to solve these challenges, we are going to use an equation of the line. To get the equation of the line, before you get the equation of the line, you have to get the graph, the binding relationship between these two scale values, so that we can be able to tell Arduino to combine these two scale values to give us the output, the result that we want. So that is it. So now let's go run down quick to the program so that we can see how we can program this. And when we get to the calculation, we get down to our math table and see those small graphical mathematics that is not complex. It's not a complex figure. It's not a complex number. It's not quadratic. It's not just a linear equation. It's not calculus. It is not dy dx differentiation. Neither is it cumbersome mathematics. It's very simple linear equation, plus and minus division. Simple, as simple as A, B, C, D. So that is it. Okay, so let's get to the program. Let's see what is involved in the program. So I have my computer here with me, and I have myself here on the other screen. So now let's see what is written on the program, and we'll write the program again. Then we'll do the practicals together, and that is it. Okay, so now we have my int. The potentiometer, I use port pin number 5. The port pin is A5, so I use A5 in my port pin, A5. Then I have int, that is our variables. I'm trying to define what I have in our variables, so for you to know how to achieve that. If I've listened to my tutorial, if I watched my tutorial on analog read and write on a serial monitor, you combine everything you have gathered in those tutorials. That is what we give birth to today's tutorials on dimmable LED. It's a combination of what we have done before. We use it to just form do a little practical on light dimmer. Very simple. Light dimmer is adjusting the voltage of an LED. You start from 0 to what? To 5. Arduino produce 0 to 5 volts. So what we are just doing here, we just use an potentiometer to adjust the LED from 0 to what? To 5, to adjust the voltage of Arduino, output voltage of Arduino voltage, using the what? The analog what? The pin, the analog pin to read, and we use the what? The pulse width modulation pin to write. So that is it. So the pulse width modulation pin, which is the A, which is what? The pin 11, and the pin 10, 9, 6, 5, and 3 are the pulse width modulation pin of Arduino. You will use them for what? To analog write. Analog write. These are the pins for analog write. You don't use other pins to write analog what? Signals. These signals have squiggly sign. That's sinusoidal. Square wave. They have square wave sign. So you use this pin for what? For your analog projects, all your analog projects. And when you want to read from a sensor, you want to read an analog voltage from a sensor, not digital, you read from analog, you use what? From A0 to what? To A5. A0 to what? To A5. So we are using A0 to A5, and I choose A5 because I want to use A5. And I choose pin number 11 that has wiggling sign because I want to use pin number 11 that has wiggling sign. So you can make your choice and choose any of these pins, and you can also write with it. Okay, so let's go to the IDE, which is here with me here on displaying on your screen. So you write our variables. First of all, we declare our port. We have the port pin, which is the port pin is what? A5. The potentiometer pin, I use A5. You put semicolon. Then you use int. The white pin, I use white pin as my white LED here with me. The white LED is here with me. This is the white LED. Okay, the white LED. So I use what? The pin 11 for my white pin, and float. Potentiometer value is a float figure. It's a floating what? It's a floating number. You can get to what? 925.6, 926.7. So I decided to use float. You can also use what? You can use int, but it's a floating figure. The port value and the LED values are floats. They are floating figure. They are floating numbers. I can choose to make it what? I can choose to use int for the sake of this tutorial, but the LED value I will leave it at float. So let me just use int on this. Int can still work. Okay, so that is it for this one, and that is the port value, the potentiometer value, and the LED value. I choose what? I use float as my LED value, LED val. So I didn't declare these ones because they will be calculated. They are floating values. They will be calculated in the mathematics by the Arduino itself. By the time you put your figures, Arduino will calculate them and give out the results. So, and I have the int long D delay because I have my serial monitor here with me. You can ask yourself what is delay doing in this program. since I'm just dimming my lights, there's no off and on of the light, just a dimmable controlled by the LED. So what is the delay doing here? The delay here is for the serial monitor, so that when it prints, it gives a space for me and delay and prints the second one, and I have a delay of 1 second, and that is it on my variables. So now I go to my voice setup. My voice setup is where you give the Arduino set of instructions on what to do. On the voice setup, I have the pin mode. On the pin mode, I have port pin is what is an input device, an input pin. Port pin is an input pin, and my port pin is what? Is my A5, where I have my potentiometer reading the voltage as a multimeter. Then it will read the voltage and will write the voltage to what? To the pin number 11, which is what? The analog what? The analog write pin. That writes to what? To the LED that gives out what? The 5 volts or 0 to 5 volts. Okay, now I have the pin mode again, another pin mode here. I have another pin mode here, and this pin mode is what? W pin. That is white pin. It's what? It's an output, and this is white pin. It's where I have my LED connected. You can see the LED connected in the white pin. This is LED connected via the resistor, and from the resistor it is connected to what? To what? To the pin 11 of my Arduino. Then you have what? You have my serial.begin. I have to put the baud rate of my monitor. Watch my previous tutorial on serial monitor. So you get how we get 9600 as our what? As our baud rate. So let's go down the program and see. Okay, then come to the void loop where we have the loop station. Okay, where we loop the program repeats itself. It begins and ends, it continues again, it begins and ends. It's a program that runs from one end to the other continuously. That is what loop means. Loop is where it repeats itself again. The program runs where you have the piston running piston in mechanical engine. You know, it continues. If the piston continues the up and down movement, the vehicle continues to move. If the pistons move, prang, 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 stops, the vehicle stops. So it must continue to loop. That is the loop, where you have your loop. So watch our previous tutorial, you understand the IDE environment and what loop means and what void loop means and what a voice setup means. Okay, so now void loop is where we have the potentiometer value is equals to what? Analog read. Potentiometer value, port val is equals to analog read. And in bracket you have the port pin, analog read, port pin. That is it. I've declared it. This is where I declared my potentiometer. This is what? It's analog read. So it's analog read, and it's what? Port pin. Return to the port pin. So that is it, port pin, and you know your port pin is what? Pin number what? Number 5, A5. Okay, now lead val is equals to what? 255 dot divided by 1023 dot. Because it's a floating number, I don't want to use 255 only without putting dot. If you don't put dot, I did not see it as an integer. Watch our previous tutorial, you will get these information for yourself. The difference between an integer and a floating number. An integer is what? A whole number. A floating number is a number between itself has a decimal number that has decimals, you know, that has decimals. Floating number, for example, 0.5 is a floating number, 1 is an integer, 2.5 is a floating number, 3 is an integer. So that is it. Because this is a floating number, I put a dot. That is how you write this program. So 255 dot over 1023 dots in brackets multiplied by port value. So this equation, how we got this value, we are going to solve it after this. Okay, so now you have analog, right? Then W pin is equals to lead val. W pin, lead val, W pin. W pin is what? The white pin is what? Lead what? Value. So white pin, you are not going to say white pin high, white pin low. No. Lead val. The value you got from what? From this calculation is what is going to be written on what? On what? On the lead what? On the lead value. Lead value. So that is the number you get from this one. Is what you're going to write on LED value, LED value, LED value, LED value. And the LED value pin is what? The LED value pin is what? Look at it here. LED val, where is it? LED value, didn't declare it is a floating number. So that is it. And this what? White pin is what? Pin 11, white pin. So now let's go. Okay. Okay, so analog write white pin. So analog write white pin is what? So it's equals to LED val. So you're on white pin, you are going to write LED val, LED value figure. LED value figure is what we are going to write here. And LED value figure is being calculated by this. So this, anything it got from this, it calculates it, the Arduino calculates it and give the LED value. So it's not a static number, it flows from what? The LED value flows from what? From 0 to what? 256 on the value and on Arduino scale value. So that is it. On Arduino scale value is from 0 to what? To 255. 0 to 255. On a real world voltage, it becomes 0 to what? To 5 volts. That is what? For the analog write. And analog read, you have what? 0 to 1023. So you are not going to say white pin. On normal program we have on a delay program, you say white pin equals what? High. No. We are going to use what? LED what? Var. This value is LED var. And LED var is equals to 255 divided by 1023 over 1023 multiplied by port value. So I will tell you how we got this calculation, this equation. I will tell you how we arrive at this equation. Okay, so that is it. So serial.print in line LED var. Serial.print in line LED var. You can say serial.print in line LED var. So this is LED var, LED value. So the LED value is what going to see in the serial what? In the serial monitor. The LED value for a scale of 0 to what? To 255 is what you are going to say. You can also say serial.print what? Port val. That means you are going to see 0 to what? To 1023 on your port value. So then I put a delay, a long D delay, and my long D is what? My long D is what? 1000. So let's go and print it out and see. Let's print it out on a serial monitor. Okay, so I have my serial monitor with me here. I will make myself very small. I will make myself very small. Okay, I'll remove myself. And so that we can see the serial monitor. Okay, so that is it now. Okay, this is my serial monitor. Let me clear output. Okay, so let's upload again. Okay, so it is at 255, which is the highest value. So now I will adjust my LED. I will adjust my light emitting diode. As I adjust my light emitting diode, you look at your serial monitor and you will see that the serial monitor values will be changing as I adjust the potentiometer. So now let's adjust the potentiometer and see how it goes. Okay, so I'm coming so that I will get the camera one. Okay, so that is it. Okay, I love this shot. This shot is okay, it's good. So you can see both of them. As we adjust our potentiometer, we also see the serial monitor and we also see the brightness of the LED. Okay, we can decide to put the light off so that we can see. We can decide to put the light off. I have somebody in the studio. Frank, help me put the light off so that you can see the. Okay, good. Very good. So we can now see the potentiometer. As we adjust the potentiometer, we can now see the value on the serial monitor changing. Okay, you see 190, you see 160, okay, 153 is changing, is going down to 56, is going down to 13, is also going down to 0, and the same thing will start increasing it. You start increasing it, and it gets to 255 while you have the full brightness of the light. Then we can put our LED, we can put our buzzer, Then we can go down again. Okay, the sound is going down, and that is it. So that is the end of the tray, and that is the end of the story. So you can now see with your LED and your variable resistor, and with your Arduino, you can achieve this project. You can achieve this. Okay, so that is it. So let's go and remove and solve the mathematics, how we got the equation, the line equation that we use to calculate the relationship between the analog read and the analog write value. How we use it to write the program. Frank, you can put the light back so that we can forge ahead. Okay, so now let's go and see how we got the equation. Okay, so let's go and see how we got the values we use on our linear equation. So let's get the equation of the line. Okay, now let's go and see. Okay, sorry. Okay, now you have the port valve. Have our port valve. Potentiometer value, PV. Port valve. On maximum, you have what? 0 to what? You have 0 to what? 1023. That is the pin A5. 0 to what? 1023. 1023. And that is what? Pin what? A5. You have the lead valve. The lead valve is equals to 0 to what? 255. 255, which is what? The spin, you have pin 11. You have pin 11. It's equals to pin 11. Okay, now what is the relationship between these two scale value is what we are going to get now. To get the relationship between these two scale value, that is how we are going to find the equation that will bind this, because they are not on the same scale value. So we are going to match them together. You cannot just match these two values together. You get confused, you messed up your program. So we are going to find the equation that is binding these two programs together. So that is it. So now let's use our linear equation. Let's do our graph, a simple maths, where you have the x and y axis. You have the x and y axis. Then here you have your y axis here. This is your y axis. This is your y axis. And here you have your what? Your x axis. And here you have your what? Your x axis. So on the y axis you have your what? The lead value. This is the lead valve, which is where you have the lead valve LV. Let me use it, LV. And this is where you have, and the 0 here, you have the 0 point here. 0 is what? 0. You have 0 here, which is 0. At 0, it has 0 to what? To 255. You have 0 to 255. Here you have what? A scale of what? 255, 255. And here you have 0 on the x-axis, and here we what? 1023. 10 what? 1023. So now when the lead value is what? 0, what the port value is also what? PV. This is where you have the port value, and here you have the port value, PV port value. Let's use PV port value, LV lead value. So when lead value is what? 0, PV is 0. When lead value is what? 255, PV is what? Is 1023. So we have to find the equation of the line. So let's draw it. It's from 0 to what? To 255. So I will go like this. 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 Okay. Good. Think I'm right. I'm getting it. Okay, got it. So this is it. Okay. Oh, nearly missed it. Okay, so at this point where you have 255, where lead val is 255 at this point, and this point is 255, PV, which is port value, is what? 1023. Is what? Is 1023. So now that means 1023 is equals to what? 255. And here 0 is equals to what? 0. So that is it. So have your port value, like I told you, it is from what? The port value is from 0 to 1023, and LED value, that is LED value, is from 0 to 55. So if you read 0 on LED value, you also have 0 on a what? On a port value. So if you also read 1023 on a PV value, which is port value, you also read what? The LED value is what? Is 1025. So let's come up with the equation of the line. So you need 2 points, which is 0 to 0, and these 2 points is what you need, 0 to 0, and what? 1023 to 255 is what you need. Is what you need for you to get the what? The equation of the line. So let's also find the slope of the line first of all. Let's get the slope of the line, so that the slope of the line here, the slope of this line, with the slope of the line, you can now get the equation of the line. The equation of the line has to go with the slope of the line. So the equation of the line says, this is the equation of the line. Let's get the simple equation of the line so that we can be able to see the slope of the line. The equation of the line is what? Y. Let's see. Y is equals y minus y plus y1 is equals to m, which is the slope, into x minus what? X1. So that is it. So we need to find what? M is what? The slope of the line, and m is equals to y2 minus y1 divided by what? X2 minus 1, x1. So that is it. So now let's convert it to our real life application. We are not using x and y. We are using what? LED value and what? Port value. And our y stands for what? On the port LED value, and our x stands with what? Port value. So now wherever we see the y, we put what? The LED value, and wherever we see the x, we put what? We put the port value. So let's start with the slope of the line. So let's rely the slope of the line and say m is supposed to what? Wherever we see y, we put what? LV. So LV2 minus LV1 divided by what? Whatever we see x, we put what? PV. We put PV, PV2 minus PV1. So that is it. Very easy and very simple. So we already know that our what? Our LV1, which is here, which is in this place, our LV1 is what? 0. And our PV1 is 0. So 0 cancels 0. So this is it now. LV is what? 0. So let's do it. M is equals to what? LV2, which is here. LV2, LV1, PV1, PV2. Okay, so now LV2, which is LV2, which is what? 255. 255 minus what? LV1 0 divided by PV2, which is PV2 is 1023 minus what? PV1, which is what? 0. So 0 goes, and we have what? Slope of the line, which is m, is equals to what? 255 over what? 1023. 255 over 1023. So you have 255 over 1023, which is the slope of the line. 255 divided by what? 1023. So let's get the equation of the line, and which is the equation of the line. Like I told you, the equation of the line is what? Y minus y1 is equals to m, which is the slope, into x minus x1. So let's go again. Any place you see y, you put what? You put LV. And any place you see x, you put what? PV. So let's go again and say, and the y1 is 0. So x1 is what? Y1 is 0 and x1 is 0. So this one goes, this one goes. So now slope, now LV minus, okay, it's already out, is equals to m into what? X, which is what? PV. So that is it. So now LV, lead val, is equals to slope, which is what? M, which is 255 over 1023 into what? 255 over 1023 multiplied by what? By PV times what? PV. So that is it. Now we have gotten the equation of the line, which is LV into equals to 255 over 1023. Sorry for putting x here, it's already okay. Sorry for this. This is LV equals to 255 over 1023 multiplied by PV. That is it. So now we have gotten the equation of the line. So with this is the formula we are going to use in our code, in our IDE. So we are going to use this formula in our IDE. Okay, so let's go to the program and use this formula so that we can be able to code our program. Thank you. Okay, so let's see how we come to this arrangement of this circuit. I will disconnect all of them. We can now arrange it back again. How we can achieve this dimmable LED with Arduino, with one LED, one resistor, and one variable resistor, one linear resistor, your buzzer, and the rest of them. So let's disconnect it and see how we got to this arrangement, and put everything back again. Okay, so that is it. Okay, so okay, wow. Okay, so now we have the LED. This is the light emitting diode. Like I told you, the longer leg is what? The positive. Now the positive, this is the longer leg, which is the positive. So I'll slot it. I'll slot my okay, let me come close so that we can see. Okay, so I'll slot it in. I will slot it. Let me slot it here. Okay, this is the longer leg, 20. Okay, now I have my resistor, goes to the longer leg, jumps over, then I have my shorter leg, which is my ground leg. Okay, now it goes to what? To the ground of what? Of the Arduino. This is the ground pin. I slot it to the ground pin of the Arduino. Slot it to the ground pin of the Arduino. Okay, so goes to the ground, from the ground of the LED to the ground of the Arduino. Then you have the positive leg, to the positive leg to pin 11, which is what we use. We use pin 11. You can see we use pin 11, goes to pin 11. So then the variable resistor have 3 legs. Let's take the first leg, put the yellow jumper, then the last leg, and the yellow jumper. Then the middle leg, you put the white jumper. Then the other end of the jumper goes to 5 volts of the Arduino. The 5 volts of the Arduino. The other end goes to the ground pin of the Arduino. And another ground pin. Ground pin. Okay, and this one goes to the A5, the center leg goes to the A5. And this is the end of the drill. This is the end of the story. And we plug in our USB so that our program comes on. And this is our program. Okay, you can now see the program. Then you adjust. Okay, so now I think I found the problem. Okay, now you can see when you dim the LED, when you dim the potentiometer, it goes down. Then when you increase it, the LED comes up. So that is it. So let's go to the serial monitor and see the serial monitor. So this is the serial monitor, and good. It's a very good shot. Okay, now let's see what goes on with the serial monitor as we increase. Let's reset the serial monitor. Let's clear the output of the serial monitor. Let's go again. Okay, now I'm going to the end, then I have 0. Then I go to the other end, I have 255. So let's get to 125. This is 130, 111, 127, 128. Okay, so you can now see that the LED and the potentiometer, they are now connected together and they are working together. Then you have, when you go below, we are now on 21. Sorry, I'm having a loose connections here. That is what is my problem, is on loose connections. Let's get these connections right. Okay, I think they are tight now. They're okay now. So let's go again and see. Okay, 255. Let's go down. Okay, it's going down. Okay, to 0. Now let's come up to, this is 48, scale of 48, this 78, this 100, this 124, this 1, this is 235, and this is 255. Okay, so that is the end of the drill. You have seen how I made my circuit, my connections, and you can see the variable resistor, the LED, the resistor, fixed resistor, and my jumpers. The relationship between all these connections, the relationship between all of them, and then to my Arduino, and from my Arduino to the system where we did the programming, and This is the end of the drill. This is the end of the drill. So on my next tutorial, on tutorial 20, I'll leave that one for me, and what I'm going to come up with on tutorial 20. So see you on tutorial 20 on our next tutorial. Okay, so this is the end of the drill for today's tutorial on dimmable LED combination of analog read and write. We printed it out on our serial monitors, and we did what again? What we did again? We did the calculation, the linear equation. So we did four things today. The serial monitor we printed, we read the potentiometer value, we print the potentiometer value, we didn't print the potentiometer value, we printed the LED value. We printed the LED value, not the potentiometer value. You can also still print the potentiometer value if you want to print the potentiometer value. You can see serial.begin, you put your baud rate, then you go back and where you say print in line LED value, you can say print in line port value, and that print in line port value, let me show you. Print in line port value here you say print in line LED value, you can say print in line port value, then you can now print potentiometer value, and this, and that should be 0 to what, the 1023 scale of 0 to 1023, and that is it. So I think we learned a lot. We are combining all our previous tutorial. We're now bringing all of them together to form a circuit to do a project, a dimmable LED. With what we have gathered today and in previous tutorial, we can start doing some complex project that involves all that we have learned. So see you next on tutorial 20. God bless you. I'm your one and only Mr. Great here in Mr. Great Tech Review Studio, bringing you technological updates. Try as much as you can to share this information, and also to subscribe to my channel on YouTube, and also to like and share our videos on our Facebook page. Thank you very much. God bless you. See you next time on tutorial 20.